that said, I would like to introduce you to the first speaker, Natalie Kilber from Harman International, and she will talk about, here it is, helping organizations anticipate and approach emerging technology threats. Natalie, the stage is yours.
Right. Good morning. It's a pleasure to be here and be first at first. Now, I'm Natalie Kilber. I used to be a quantum physicist and long has ventured into the cyber realm. I used to work for venture capital, startups, been a government evaluator for funding, and now senior director for product security at Harman. And I would like to thank John Doyle for his patience and dedication to the talk, which is helping organizations anticipate and approach emerging technology threats. This talk is all about how you can apply CTI methodologies for assessing emerging threats. CTI is well equipped with the process, so the methodology is laid out for present threats, as you can see. But the extended part for introducing and assessing emerging technologies, we need to adjust the sources that we intake. We have to, after the analysis and contextualization, translate them back so we can communicate to different stakeholders with consistent metrics. The stakeholders could either be senior leaderships like CISO, risk leadership, or either operational people like SOC analysts, or just CTI people that you share it with. Now, can you please raise your hand if you know these two models, any of these two? Perfect. That's perfect. This is the power of common language models. You're able to communicate without having to define the prerequisites. It is a common ground. You don't need to redefine everything. And that's perfect when it comes to consistency, because humans and their psychology have familiarity bias. So by reusing these, we're more familiar with them, we're more likely to accept whatever is being said. That's just human comfort and cognitive resonance. So it's perfect for reuse. However, again, for emergent technologies, we probably need to adapt them a little bit. And that part is usually, within emergent technologies, how you assess the maturity of technologies that you haven't seen yet. So there are a couple of them. And I'm not going to explain all of them, because if I would do that, that would take forever. However, I'm going to focus on the NASA technology readiness levels. I want to make it simple, just have the barometer, so I can dispel the complexity behind it, and that we're anchored in a methodology, a framework that has been used since the 1970s with the DoD. In the 1970s, during the space race, the DoD used, or developed, didn't just use it, it developed it in the 1970s. It developed it in the 1970s during the moonshot paradigm. So within the space race, they were trying to estimate the maturity of the technologies so they could be the first one in space. And now it is widely established by credible sources, either being NASA, the European Space Agency, the European Union is using it, the ISO standard bodies, or even deep tech investments are looking into NASA technology readiness levels. And since the 2000s, the DoD even announced that this is the procurement model for it. Now, this again, I'll keep reusing to dispel complexity, but also have it with consistency. So we can leverage the cognitive resonance, and especially the cognitive resonance that is pertinent to credible sources and authorities like NASA that stood the test of time. So it's easier for senior leadership to accept this model than any other. Or more likely to accept it than others that are not as widely adopted by authorities. Oh, sorry. So then to dive into the barometer, just to make it a little bit more tangible, different technology, the same technology and different aspects of it can be on a different level. For example, if you look at drones, So drones for package delivery, they would be somewhere between 8 and 9. So it has been proven in some sort of way, but not fully, and the system is complete and qualified. But drones, in a sense, for space mining, for example, they would be absolutely in basic principles observed. Or drones when it comes to road flight. So if you have drones that you want to sit in and instead of a car, that would be about technology concept formulated or within the proof of concept. So technology readiness level 2 or 3. This barometer relatively easily shows at which stage the technology is, either research, development, or deployment. So I would like to keep reusing it. And to get into the CTI lifecycle now, so what is the direction? How do I translate this into the overall picture in the first stage? And that's to integrate the technology readiness levels, or TRL, into market viability. So when is the market readiness and when do threats become tangible? Again, here is an example. This is a very complex one. The TRLs are in the yellow at the bottom. And as an example, away from the drones, space mining would be in TRL 1 to 4. So that's research and development. But if you look into chatbots or NLP, so natural language processing, they've been there for a long time, and they would already be in a market readiness level. So the orange part, towards the orange part. However, LLMs have emerged out of a tangible red ocean, so an already saturated market, but a relatively new technology. So they would be coming from TRL 7 to 8 into a technology that has already existed in the market. Now, our common language models like MITRE ATT&CK or Diamond model of intrusion analysis, they would be within this green space. These are present threats. These are real-world attack observations, and they're situated within already market readiness levels 10 and more. So they've been accepted, they're being used, they're already deployed in most cases. And in some cases, like for example the MITRE Atlas matrix, Atlas meaning the adversarial threat landscape for AI systems, that one would be well into TRL 7 and then with higher maturity. If you then look into technology readiness levels 1 till 5 or 1 till 6 roughly, you see a lot of theoretical exploits. Theoretical exploits mean we have it mathematically proven, this could happen, but we don't have a proof of concept. So there's no public exploits or no proof of concept on hardware in itself. So it's something that could not be demonstrated on hardware. With that, I'm coming to the different sources. So now we know the overall direction. What are the different sources that I need? And for here, I made a relatively high-level summary. For the required readiness levels, you need different intelligence sources. This is also an opportunity to be able to have early change indicators of what the situation is, what the maturity is, and what adoption is. It is also an opportunity to quantify the intake of data sources and be able to parse or crawl through certain outlets and then see if that keyword that you're looking for, that key technology that you wanted to look at, is already at a certain stage. So you can evaluate the relevance and the maturity of a threat and the early change indicators, as said. Now going through the table. I coined it mature development research and then hype at the end. So mature technologies are within TRL 7 to 9. Here, the data sources are either mainstream industry news, initial public, so IPOs of startups, or the stock market in itself, so the financials, as you can see. The development is within TRL 4 to 6. There you see startup investments like Series A until Series F and higher. So something that is being developed but not in the public market yet, or not fully integrated into the public financial stock market. Also market analysis outlets like Gartner, for example, You look at patents in some cases, or technology licensing, depending on the technology. In the research stage, TRL 1 to 3, you look at scientific publications or research funding. And to make a bit more tangible, for addressing hypes, you already have to be in the analysis. So it's not just looking at the sources, but after the analysis, which is, again, each maturity stage is difficult to assess because it might seem subjective or difficult to define as it depends on context. You have to do this after the analysis, and here structured analytical techniques from the CTI field are absolutely helpful. So analyzing these, the early indicators are that technology is presented as TRL 7 to 9, whereas in fact it is at the TRL 1 to 3, if at all. So TRL 7 to 9 sources are being found, but the whole field is mainly driven by the output of TRL sources of 1 to 3. So it's driven by scientific publications, for example. So anything new coming out of research is heavily driving the field. However, it already has companies that are in the stock market for that specific emergent technology, and it is heavily hyped, or it's heavily represented in the mainstream media, for example. Now looking into collection. So what are extended intelligence sources? So how do I collect these? Now we know the overall direction. We know how what different intelligence sources you would roughly look at. But how do you collect them? And at one example here, the case study, the quantum threat, I would like to run you through with some high-level examples. So the quantum threat, before I dive into it, as we've seen, is technologies can be highly complex. And because they're highly complex, I have to come again and read and define them, so we can be specific in assessing them, and to be specific in categorizing them in the barometer, as it is. So the quantum threat refers to the risk posed by quantum computers to our cryptographic schemes. That is the overall definition of the field, what the quantum threat is. So we're focusing heavily on the current cryptographic schemes that the quantum computer or the quantum computing resources are a threat to. Now jumping into the data sources. So TRL 7 to 9 within mainstream media. We have been bombarded by the news with quantum threats to act now. So World Economic Forum, we have one article that we have to protect it against the quantum threat. Then we have Forbes saying we're one step closer to securing our nation from the quantum threat, more on the NIST side. The quantum threat is real, now we need to act. That's from the National Quantum Initiative in the US. Or, now this is dark reading. However, this is an article where the Mitra general manager has been interviewed, and his take was, the entire tech industry needs to move together with an urgency. And if the Q-Day is 5 or 50 years away, sensitive data and communications are vulnerable to exposure in the future without immediate comprehensive action. So that's what I get from mainstream media. Looking at a different data source from technology readiness level 7 to 9, so initial public offerings of startups, meaning that startups went into the stock market. I can see D-Wave, but D-Wave is trading under $1. So they're not doing that well. I can see Rigetti Computing, roughly trading above $1, sometimes below, sometimes above. Quantum Computing Inc., also trading below $1. And IonQ Inc. trading well above $10. But then you have also the possibility to dive a little bit deeper at this example because it's not quite apparent. The financials also do not look that rosy because the earnings per share that you can see at the bottom, they're also not hitting the mark, or that the net profit margin is not working well. These are all public sources. And for context within financial markets, if you trade under $1 for more than 30 days, you're usually being delisted. So that already shows that it is being difficult for these companies. Technology readiness levels 4 to 6. So we're looking at market analysis outlets, as I said before, Gartner, or we're looking at tech blogs. D-Wave is about to be delisted. That we have through Gartner. Then, more specifically, the quantum segment is also highly fragmented with an estimated 600 plus startups and some established companies currently operating in the space. This level of market activity is unusual and unsustainable for a market segment that currently does not deliver business value. That coming out of financial analysis of a market analysis outlet like Gartner. That specifically was from a Gartner VP analyst for quantum technologies and AI infrastructures called Chirag Dekade. So what is also interesting is Gartner did not include quantum computing in its top tech trends in 2024. So this is all relatively interesting to intake as of now, without bias, without analysis, just having the intake in the first place. And now going from technology readiness levels 7 to 9, 4 to 6, a little bit deeper, we're at a very difficult spot. And it's usually it's a very difficult premise to understand a subject if you don't know the technology. Here, there's also an opportunity to collaborate with your R&D people that might be closer to the field. But you can also just look at the publication output in, for example, quantum computing, and look at data sources that are referring to mainly the scientific publications for advancements that you can already infer. And scientific publication sources are usually not well known in the CTI community, so I'm just throwing them out here. Archive.org is a free one, Web of Science is a free one, and Google Scholar is usually the ones that you can then parse for keywords. These would be some of them. So this is also pertinent to the quantum threat. The quantum threat is only a threat to asymmetric cryptography, meaning PKI systems. Especially only the Shor algorithm that is behind the factorization. So the main premise, the main part of the theoretical exploit is that you can break PKI like RSA, but you cannot break symmetric cryptography like AES 256-bit. That is unbreakable by a quantum computer. Here you can see asymmetric cryptography like elliptic curve, discrete logarithms can be broken by it. That is one scientific paper by Microsoft. Then you can see by Google, RSA can be broken in 8 hours with 20 million noisy, so physical qubits. And then we also had a paper, and here you have to be careful again with people knowing the field. We can break RSA within 177 days with above more than 13,000 qubits. But here with a multimode memory. And multimode memory means it's a quantum random access memory that doesn't exist as of yet in the field. We don't even know what type of material could be used to be part of a quantum realm, because it's only read-only memory at this point. So for the hardware in itself. These are incredible results for the scientific field. But how do you evaluate these citations in credible sources? What I've shown you now, they're all peer-reviewed. They're already in journals, so other scientists have checked them, and they've seen if they're reproducible mathematically. So they've been accepted by the scientific communities. But there are also scientific papers that are non-peer-reviewed. So for example, here out of arXiv, you get preprints. And preprints are things that you can publish before there is a peer review. And there you have to be really careful. This is a new paper about an efficient quantum factoring algorithm that halves Shor's algorithm's time. So it's even twice as fast, so to say. And December last year came out a paper by a Chinese university claiming that only 25 qubits are enough to break RSA 2048-bit, which was debunked because it wasn't a preprint, and in the end it was bogus after peer review. Now, going into, this is all theoretical, and we've seen the mathematical exploit in itself, that how you do math, but the actual implementation of this, so how do you do factorization, we've also seen in the scientific publication, so when you dive absolutely deep into the topic. So in a paper by IBM in 2019, we actually have the factoring of the number 35. By now, well, it was 2019. By now it is a little bit higher, but still under 3 digits. So the theoretical exploit in itself, as in Shor's algorithm, has been demonstrated, but not to the extent that we would like to see. It's just the bare bones. Now going into the analysis. I've already done the analysis a little bit at the end now with the scientific papers, and you can go arbitrarily deep in your collection phase. These are just some examples. So when we then dive into the deliverables or timelines, we have to contextualize this back into what either our stakeholders know or what you know, if you've also involved collaborators from your R&D phase or collaborators from your finance department. Oh, sorry. Oh, yeah. So within the technology readiness levels 1 to 3, analyzing them can also mean using scientific or publication database analytics. There are already organizations out there or tools out there where you can use contextualization without having to do the data science all by yourself. So it's either Web of Science, Scopus, or even Google Ngram Viewer for some ways that you want to do it. So Google Ngram Viewer, for example, I've hinted on it before. The quantum factorization, the red line you can see, is the premise behind the quantum threat. So it's the quantum cryptography, and how you can break that is quantum factorization. This premise has been superseded by the narrative of a quantum threat. That is already an interesting indicator what might be happening. Then out of Scopus, you see that the hashtag or the tag in itself, quantum cryptography, within scientific publications, is mainly funded by Chinese national government bodies or Horizon 2020, also the European Commission, but predominantly by Chinese funding bodies. The quantum threat is also, as a tag, funded by Chinese funding bodies, Horizon mainly. You can see that the quantum threat is a lot less because it is basing on quantum cryptography. Quantum cryptography is a lot bigger, for example. So you see a correlation there. And looking by the documents produced in the country or territory with the hashtag quantum threat, that it is mainly the United States and China that produce these papers with these keywords. Then quantum cryptography, again, China and United States, just to contextualize this. These are also some early indicators, especially with the threat narrative overtaking the actual premise, that it might be an economical race between the US and China, at least in the funding phase. Then, of course, you need to contextualize and go a bit deeper. So what are actually the attack scenarios that I've seen in the publications or the mainstream media? So what is the common denominator there? So with analyzing the output from the data sources. And the common attack scenarios are either brute force, which would be pertinent to Grover's algorithm, but there's no demonstration of it in any scientific paper. It's always a mathematical, theoretical exploit. So how you can foster brute force through dictionary search, so to say. Harvest now, decrypt later. I think we've heard that all. Or who hasn't heard of harvest now, decrypt later? No, perfect. So everyone has heard about it. That means that in some way or form, an adversary can harvest your data, store it for 20 years, and then decrypt it. Here, I would like to challenge, either it is untargeted, so you just harvest a lot of data that you don't know what might be in there, so it might be terabytes of data, even if it's just at a router of a company. But if it's targeted, and we will see that later, there needs to be a lot of staging up until you exfiltrate certain things. So the question is, why don't you use classical means to get to it? But that's up for discussion. And then, of course, network sniffing. Usually, there you see the idea behind it being also untargeted. So you have border gateway protocols that they are just harvesting all the data and information. Diving then a bit deeper in the analysis, now we know the attack scenarios, but who are the threat actors that could do this? So what are the capabilities, motives, and the skill level or size of these threat actors? And of course, then also tactics and techniques behind what they could do. So the capabilities of threat actors are clearly you need to have physical access to quantum computers. The quantum computers that you use over the cloud are for educational purposes, and usually simulators. If you want to have compute power with a emergent technology and hardware, you need to have the hardware access to it. So you can do proper error correction, and you can also adjust for runtimes. And you can actually stage memory in it, and so to say. So you have to have physical access to quantum computing. You've seen the Google paper with 20 million noisy qubits. That also is pertinent, that you had physical access to the quantum computing hardware. So a threat actor that is in Russia might not have this, because Russia is not funding quantum computers as China or the US or Europe. And their hardware development is also not as far, meaning they might have a quantum computing institute, but they do not have a fully working quantum computer physically present in Russia. So for example, Wizard Spider, if they may be funded by the nation state of Russia to do certain things, they're located somewhere in St. Petersburg or Ukraine, they would not have the physical access to the capability to a quantum computer, so they could not use that quantum threat attack scenario. Of course, they also need a lot of storage. If it's Harvest Decrypt now, they need to have a skilled workforce, and they should be able to stay dormant for 20 years. So in a sense, it couldn't be Wizard Spider, because they have no access to the hardware, and neither would they be able to have that in nascent time, or near term. Usually the motive here is also espionage. So why do you do Harvest Now, Decrypt Later, or exfiltration of data? And want to stay dormant for 20 years, so it's usually espionage. And the adversary cost must be exceptionally high. So Wicked Panda, a Chinese actor that has access to a quantum computer physically, but, well, we have quantum computers in China and the physical access to the hardware, but we do not know what the state of the quantum computer is, and if it's better than, for example, the US's with Google or IBM. And here again, the skill level of quantum computing resources, so the talent behind it is also there, because they're funding it heavily. So they also have the talent. And as you can see, translating this back into our common language nodes. Now this has been a lot of information, but translating it back into what you know. And not just translating it back with what you know, but within the anticipation of the risk, you also have the ability then to hunt, manage, and create processes that will mitigate exactly that threat, and for emergent threat, that proactively. So within the MITRE ATT&CK enterprise matrix, you can see network sniffing, data exfiltration, you see some brute force in a little bit of blue. But what I'd like to focus on, these are extensions of techniques and tactics. So the detection is similar when we look at all the staging up until the threat actor uses this. So what is the attack path? Thus, how can we detect the activity before that happens? And meaning within the staging, the adversary has to do this by classical means, but things that we already know. So we're translating it back into what is relevant to our organization. And here again, as I said before, if an adversary knows where to get the data decrypted and has the resources for espionage, why not use all the other available tools? So that's also one way to look at the risk anticipation if you want to translate it back into risk. However, threats develop. They do not suddenly pop up, and as technology develops, so do threat actors. There are no public exploits yet, and the adversary cost is absolutely high. But you have to monitor that. Now translating it into our barometer, so the technology readiness level of NASA. The quantum threat risk posed to public key cryptography is around the technology concept formulated. So we've seen some attempts of POCs, but in itself it's a theoretical exploit, meaning we're at technology readiness 2. And then back into the diamond model, the adversary has questionable adversary cost. Quantum computer costs about minimum 2 million, and the setup of the laboratory, the energy behind it, it's about a lot more. And again, it's not for Russia, but more China and United States that have the capabilities, or Europe for that matter. It's not criminals or hacktivists that are usually that need to operate cost effective. The capabilities are also physical access to quantum computers. Again, the staging, initial access, lateral movement, defense evasion, up until you get to the network sniffing and exfiltration. The victims in itself have government proximity, or data with long intelligence lifetime. So the victim usually then connects to either some BGP hijacking if it's victim agnostic, or again with C2 channels, etc. Now, to simplify for senior leadership, I mean, these can be already used in some sort of sharing with operational teams, but for senior leadership, I would like to use one example. So how do you contextualize back into the production for communicating with, for example, risk management or CISOs? Here, again, risk posed to public key cryptography, the parameter, and a couple of key points on a one-pager. Because senior leadership will not read about a 40-page document. And here again, the intelligent threat is inflated. Sorry, the quantum threat is inflated and will remain about theoretical for at least the next 20 years. That is from an output from quantum computing researchers that are developing the field and have a substantiated standing in the field. So who should likely care? Those with government proximity, meaning even before there is a public expert or before the technology is there, you might be affected by true compliance because NIST is telling you that you have to use this in some sort of way. So the government proximity is the one driving this. It also predicates that threat actors need to be able to tap into core fundamental research, have certain funding streams, have quantum computing skills, access to quantum computing hardware, etc. And the current states of play are usually China and the United States as of now. Now, a highly complex field is made simple with the barometer, and it's easy to communicate this and dispel complexity. Moving back into the proactive scoping. Each section that you can see here can also be an indicator to reevaluate. As I said, technologies evolve. So with each of these sectors being, moving from research and development to field validation to scale up, so from TRL 1 to 4, 1 to 3 to 5 to 6 and further, is also an opportunity to reevaluate your data sources if you do it manually. Or if you have crawlers that then indicate that these sources have moved on to a higher technology readiness level, you might need to look at it. Or you can turn it around and actually set the scope and triggers. So you can dispel what leadership should care about depending what TRL level it is. So for example, set a threshold to TRL level 6 and telling leadership, look, these are theoretical exploits. These cannot be used as of now. Meaning that you take back control and take back the beat of how you want to do your scoping and focus. Here again, through consistency in delivering information to senior leadership that has value to them and has simple enough messages so they can understand it and anchor them into their decisions, this also directly translates into business value. On another note, you don't have to take the TRL levels, you can also just look at certain outlets. So for example, if you have IPOs of startups going public, or if you have field validation or investors coming in, these are usually sequential points. So you can set sequential points and triggers for that to happen. Now, my key takeaways for you are, for one, be proactive in emergent technology assessments. You actually have all the tools and you can leverage common language models, but you should stay consistent with it. And then again, You have always the takeaways that you have methodologies you can point back to and use these human heuristics and biases to your advantage, like cognitive resonance, familiarity bias, that you show consistently what you've done, and of course simplify messages so your senior leadership can anchor their decisions in something simple that they understand and are not confused. So that also means you can provide value to your organization by contextualization of emergent technology threats, so leaders can then take informed decisions, and you are in a position to influence their decision making. With that, I thank you. And before we start questioning, in the meantime, I would like to point out I also have a quantum perception survey in research. If you'd like to take the survey, I would be very happy. Thank you for that. Thank you for your time.